So Chapter 11, Introduction to Organic Chemistry. This will be segment 1. For organic chemistry, what we're going to do is change gears completely. And so all the things you've kind of been learning up to this point are kind of out the window now. It changes gears quite a bit here. In this chapter, what we're going to do is we're going to focus on just the organic compounds, which means we're going to look at the basic building blocks of alkanes. That's where it starts. Then we'll look at alkanes with what we call substitutions. Then we'll look at properties of alkanes. And then we're going to finish off with functional groups. And functional groups are how organic compounds react. Okay, so this is just the tip of the iceberg. Typically, for organic chemistry, you would take a year-long course in organic chemistry. So we're not going to go nuts here and think we're going to know everything about organic, but we're going to give you the basic building blocks of organic chemistry. Okay, so in this introduction here, what we're going to be looking at is the chemistry of carbon compounds that contain primarily carbon and hydrogen, right? So things like gasoline. If you put gasoline in a vehicle to get to school or work or just to go to the grocery store, do some shopping, gasoline is an organic material. Another one that you're very familiar with would be your medicines. Medicines are almost always organic in nature. Sometimes, well, I shouldn't say sometimes, quite a few of the times, there'll be a chloride on the end. That's just so that we can get soluble in water, because we're going to find that most organics are not going to be soluble. Plastics are all organic, so it's all hydrocarbons. Perfumes, organic. And most importantly, food. Food is organic. Now, we've talked a little bit about food when it came to the heat chapter. We talked about carbohydrates. Carbohydrates are hydrocarbons. Fats are going to be hydrocarbons. And what was our other one? Carbohydrates, fats, and proteins. And proteins are definitely going to be organic in nature. All right, so again, starting off with the basics, the first thing we look at are the alkanes. And so you've got some new names you have to learn. We have methane, ethane, propane, butane. Those are probably the 4 new ones. After that, you're going to start to see something you already know. So pentane, we already seen that prefix, pent. Hexane, heptane, octane, nonane, and decane. Now it keeps going, but just like our Greek prefixes, we're going to stop here. So 10, and what we're going to find out is 10 carbons. So that prefix is telling us how many carbons are there. So meth means 1. That's not to be confused with meth like on the street. We're not talking about that meth. That's a different meth. Meth here is a prefix, means 1 carbon. And so that 1 carbon has to have 4 bonds. So if you think back, when we looked at bonding, we had carbon, and of course it's going to have 4 dots where it can make 4 bonds. And so for methane, we're going to have all 4 of those bonds simply be hydrogen. Now, the unique thing about carbon chemistry is that we can essentially pull one of those hydrogens off and stick another carbon on and have the chain continue, and that's going to be ethane. So eth means 2, and it means you have 2 carbons there. Now here we're showing the linkage of CH3 hyphen CH3. All we're really saying is that we have the 2 carbons connected. And then you can think of this as called a condensed formula. We haven't really talked about that yet. That's going to be in this chapter where we talk about condensed formulas versus expanded. So these would be the expanded formulas here that I'm writing out in red pen. But the condensed formulas are the ones that are showing up on the slide here. Okay, so you can think of it sort of like opening up an umbrella. So a lot of times in organic chemistry, because you can see writing this out can kind of be a pain. So what we'll do is we'll collapse it down into that condensed format and then write CH3 bond CH3. All right, so again, what we can do is just keep adding carbons. And so for propane, that's going to be 3 carbons. And so again, you can see I'm using the condensed format here. No big deal. Don't let it confuse you. And we're going to practice throughout the slideshow here, going back and forth between the 2. Butane means 4. So we have 4 carbons in a row as butane. Now, once we get here, you can see it's going to start to get complex because I have 4 carbons. That's what the butane is telling us. But it doesn't necessarily mean it's got to be a straight chain. So I have 4 carbons here and I have them linked 1, 2, 3, 4. But we're going to find out a little later that that's not how it has to be. And so things can get complex real fast. As that number increases, the way things are connected can change quite rapidly. So pentane will be 5 carbons in a row, hexane 6, heptane 7, octane would be 8, so there's 7 of them, and there's your 8th one. Remember, that would be linked on at the end. Nonane, again, that would be linked as well, and then decane, so 10 carbons in a row. And again, as I was saying, when we look at organic nomenclature can get very complex very quickly. Just like before, our naming system has to be able to tell us what's there and how many is there. So the naming system does have to be able to tell us the number of carbons, and what we do is we say in the longest chain, and we'll call that the parent chain. So the longest chain is called the parent chain, and that's the one that's going to matter the most. That's going to be our backbone chain, and then there are going to be other things that come off of that. Those other things are called branches, and so we have to know the locations of those branches. We also have to know functional groups. Now in this course, we're not going to learn how to name functional groups on compounds. We're going to learn to identify functional groups and what they're called. So again, we won't have to worry too much about naming functional groups per se. Like I'm not going to give you a compound that's, and say name it, and it's going to have a functional group in it. I'm going to give you a compound with a functional group, and I'm going to say what is the functional group in this compound. Okay, so you won't have to name functional groups. In fact, if you were taking an organic course, usually what we do is you start with what we're doing now, alkanes, and then the next chapter might be alcohols. You'll spend a whole chapter on that functional group. Then we'll move to ethers. You'll do a whole chapter on ether, so forth and so on, through all the functional groups that we're going to talk about. So each one of these functional groups we're going to look at in this unit would be a chapter in an organic textbook. So now the IUPAC system, that's the International Union of Pure and Applied Chemistry, they have a nomenclature system that's going to provide a uniform set of rules that we can follow to name these things. And that's what we're going to work through. So the first rule is you have to find the longest carbon chain. Now, that's not going to be an easy task. Sometimes it's quite simple. Other times it'll be very complex. And so the way I like to think about this is if I go to Lowe's and I pull out a long chain and simply cut it, and then let each one of those little rings represent a carbon, and then I throw it in a bag, mix it up, and throw it on the floor, is it going to come out so that it comes straight across and make it easy for me to count? And the answer, of course, is no. It's not going to be straight across and easy for me to count. So finding that longest chain can sometimes be the most difficult piece. Now, once you find the longest chain, you're going to number it. And we're going to go through some practice problems for this. Once we've numbered it, we're going to locate any of the branches on the chain. Now, there's two things that are going to change with the branch. Number one, remember we just numbered the longest chain. That number represents the branch number. So that's telling me the location of the branch. So it might say like 3, and then it'll say methyl, and the YL ending methyl is telling me it's a 1 carbon branch. So remember, meth was our prefix for 1 carbon. So if I put methane, then that's a 1 carbon compound. But if I say methyl and put a YL on the end, that's now a branch, which means it's going to be 1 hydrogen less. So it's going to be CH3, and then it's going to be connected to the parent chain. All right, so that's how we do our branches. Now we're only going to do methyl and ethyl because once you get to propyl, again, I told you it gets complex. So when you think about propane, you have 3 carbons. And as it turns out, if we're looking at a propyl branch, we can connect here, or we can connect on either end. And that actually changes up the compound. You're kind of familiar with this if you've ever heard of IPA, isopropyl alcohol. Isopropyl is telling us that the alcohol is in the middle versus propyl alcohol or N-propyl alcohol, where the alcohol would be on the end. So again, we're not going to worry about that detail. That was just a sort of a FYI. Our branches are always going to be either methyl or ethyl. And we're not going to go past that for this chapter. Now, once we have our branches, we could potentially have multiple branches. And if we do, we'll use the prefixes di, tri, tetra, and tetra, penta, hexa, hepta, so forth and so on like that. Now, the location of the branch will be the number. I already pointed that out. And again, we're going to do some practice here to help us out with these things. Now, you also need to list in the name the branches alphabetically. Now, don't use prefixes. So like if I have an ethyl and a methyl branch, I'm going to name the ethyl, then the methyl, then I'll give the parent name. So the parent name is always the last thing we do. All right, so let's jump right in. Now what I'm going to do is when we draw out our compounds, I'm going to leave the hydrogens off of the compound. That's going to make it easier for the chain to be seen. and it's also going to make it easier for you to draw. So we're not going to worry about that as much. Now, if you were to continue on the organic path, you're going to want to know where those hydrogens are. It's going to be very important to be able to draw out the entire compound. For this one chapter, I'm going to be obviously very lenient with this, and I'm not going to worry too much about it, especially on the computerized exams. Just being able to put that carbon chain in is going to be plenty. All right, so we're going to start out with a carbon chain, and the first thing we're going to do is going to literally just count here. So we have 1, 2, 3, 4, 5, 6. So we have a 6 carbon chain. So since 6 carbons is the longest chain, we're going to use the prefix hex. Now at this point, there's nothing else there. It's all single bonds and it's all hydrogens. So we're going to use an A and E ending, and we're going to call this one hexane. Now that was pretty simple because it was one of the first 10 that we saw. Nothing real difficult about that. So let's just take a little bit of a twist to it. I'm going to use 6 carbons again, but this time I'm going to take one off the end and put it in the middle. So now we need to count and find our longest chain. So now what I like to do is just count a whole bunch of different directions. So I'm going to go 1, 2, 3, 4, 5. Now notice it had to be a continuous chain. So this one got left out, and that's fine. We're going to deal with that as a branch. So if it's not in the continuous chain, it becomes a branch, and we'll have to number it. Now whenever I identify a branch, I always want to go back and count just to make sure. Now this could be 1, and now this guy up here could be the branch, and that's okay too. Now once I know I've got the longest chain, which apparently seems to be 5, I want to count it back the other way. So I'm going to go 1, 2, 3, 4, 5. Or I could go up here and this one could be 5. Now the reason why I want to do that is because when we're naming, we always want our branches to be in the lowest position number. The lowest position number. So to make life easy, I'm going to go straight across 1, 2, 3, 4, 5 and backwards 1, 2, 3, 4, 5. So I'm going to let this guy up top here be our branch, okay? Because I don't want you to get confused with that part just yet. When we make it a little more complex, we'll let it get a little confusing, stretch you out a little bit. All right, so that one's going to be my branch. Now that means that the position number is going to be based on the carbon it's connected to, and I'll put a triangle around that guy. Okay, so that's the one that's going to determine the position number. Now when we counted left to right, this became number 2. When we counted right to left, that one became a 4. All right, so now what we want to do is pick the lowest number. And so we're going to pick the 2. And we're going to count it from left to right. Okay, so that would be the correct way to do that. We're going to go 1, 2, 3, 4, 5. That makes the carbon branch on the position number 2. Now when we put all that together, the first thing we want to do is get the longest carbon chain, which we got. We said it was 5. That means we're going to use the prefix pent, which means the parent name becomes pentane. Now for us, all of our parent names are always going to be anes. Okay, so you don't have to worry about that part. That ending changes if we start to put functional groups in. But as long as we're not putting functional groups in our naming compounds, then it's always going to be A and E, ane. And so that means our parent name here is going to be pentane. Now we determined we had a CH3 group. It was a single carbon on the second carbon. The branch then becomes the methyl group. Okay, so we have 2-methyl pentane, and that's how we put it together. So we give the position number 2, then a hyphen, and we say, what is that position? That position is a methyl. And then without any spaces, we say that's connected to a pentane. And I ran out of space, but you get the idea, hopefully. All right, so again, if you know your prefixes, this becomes a little bit more simple. So meth we know is 1, eth is 2, prop 3, but 4, pent 5, hex 6, hept 7, oct 8, non 9, and dec 10. And of course I joke, I see much memorization in your future, but realistically, that's probably not true, right? Most of those you already know. So really there's only 4 new prefixes there for us, and that's meth, eth, prop, and but. So the more and more you practice with it, the easier and easier it gets. In the meantime, we'll do some practice problems. So here we go. We're going to do this in order as number 1, number 2, and then we'll do number 3 down here at the bottom. Each one getting a little more complex as we go. All right, now the first thing I did with these, remember I said finding the longest chain can sometimes be the hardest thing you have to do. Well, here I've already identified the longest chain for you. So It's in blue, but you do need to count it in both directions to figure out which direction to go. So since it's in blue, we'll go 1, 2, 3, 4, 5, 6, and 7. And then of course I can count it backwards the other way. Now when I do that, I've got 2 carbons here that are branches. Now, this is not an ethyl branch. The ethyl branch means the 2 carbons are connected. This is 2 individual single carbons. That means each one of these is going to be a meth, which means we have a dimethyl, right? Because we have 2 methyl groups. Now, once we've determined we have 2 branches, we need 2 position numbers. Now remember, we always want the lowest number set. So we got 1, 2, 3, 4, and then this one would be 5. Or we can go this direction, 1, 2, and this one turns out to be a 3, and this one turns out to be a 5. So as it turns out, it doesn't matter which way I numbered it, left to right or right to left. In both cases, we end up with 3, 5. Now I need to tell the reader both positions. So the way I'm going to do that is I'm going to say 3, comma, 5, and then what are those 2 things? It's a dimethyl. It's 2 individual methyl groups. My longest chain is 7 carbons, and so that's going to be heptane. And so that all becomes one big long word, 3, 5, dimethyl heptane. I don't know why there's a space here. I'm not sure what I did there to cause a space. There should not be a space there. It's one big long word. All right, so I'm going to give you a few moments here. You can pause this and give that second one a go, and I'm going to go ahead and give you the answer, and then I'll explain the parts. All right, so hopefully you paused it, you took a shot at this, and you ended up with 3-ethyl 5-methyl heptane. Now, how did we get there? Well, again, we're going to count straight across. 1, 2, 3, 4, 5, 6, 7. So that got you the heptane, right? That's the other thing I can say about organic naming versus your inorganic naming. Your inorganic naming, you either got it right or you got it wrong. You had 3 different naming sets that you had to follow through that flow chart. Here you actually get points for each piece that you can tell me. So even if all you can do is get a parent chain, that's going to get you a +1, right? So organic names, I typically put 3 points on them. You get 1 point for the parent, 1 point for the branches, 1 point for the positions. So if you're figuring out each piece, then that means you're going to maximize your points. But at least if you can figure out, hey, this is 2 carbons, that's an ethyl, and that's 1 carbon, so that's a methyl, right? So let's say I got the wrong position numbers, but now I just picked up 2 points because I have ethyl, methyl, heptane. Even if I mix them up, even if I said methyl, ethyl, heptane, all right, I'd still give you 2 points for that out of the 3. Now the position numbers, how do we get those? Well, if I just go straight across, it's 3, 5, but that's not actually correct. That's just happenstance, right? So remember, we're going to number back the other way. 1, 2, 3, 4, 5, 6, and 7. So again, we end up with that 3, 5 combination. So now the question becomes, do I put the ethyl on the 3 or do I put the methyl on the 3? And if you remember a couple slides back, we said alphabetical order. That's what I was talking about. We want to put things in alphabetical order. So in this case, I can put the ethyl on the 3 because I want to give it the lowest number, right? I want it to be in alphabetical order. I want the E to come before the M. That's the alphabetical order part. And if I can give the ethyl the lowest number, I will. Now, let's say they're moved over. And so we have 4 and 2. So now I'm going to have 2-methyl, 4-ethyl. Now, if that's the case, I'm still going to write it out in alphabetical order. So it would have been 4-ethyl, 2-methyl heptane. But I'm still going to give the lowest position number to the lowest possible position. So if I would have counted back the other way, that would have been 4, it would have been 4, 6. All right, I don't want 4, 6. I'm going to want the 2, 4. So we always want the lowest numbers first, then alphabetical order if possible. Okay, but when we go to write the name will always be in alphabetical order, irregardless of what the position numbers work out to be. All right, so hopefully we've got that one under control. If you've made any mistakes, my explanation made sense to what you'd missed. And that being the case, let's move down to number 3. And again, I'll pause here so that you can give it a shot. All right, and hopefully now you paused. You've got an answer written down on paper. And now we're going to compare it to my answer of 2,3,3,7,8 pentamethyldecaine. All right, so obviously we have a decane. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you struggled with this for some time here, got some good news for you. This one is way crazier than anything I'll put on a test. All right, so those first two, I think they're kind of fair game. The second one is a little bit on top end. Have to remember the details of the alphabetical order and getting those position numbers right. That would be top end. That would be like the hardest thing I'd ask you on the test. This one, if you nailed this, excellente, because that one's going to be tough. And if you got it, then good job. You understand what's going on. All right, so when I count 1 through 10, that gives me position numbers 3, 4, 8. Now, these are two individual carbons, but they're both connected to that position, so they're just going to share the position number. It's no big deal. And then 9. And obviously that's not going to give me the lowest numbers. If I go back the other way, I go 1, 2, and right away I can see this one was a 3, this one's a 2. That means I'm going to go from left to right, excuse me, from right to left, and get the position numbers that way. And that's how I'm going to get the 2, 3, 3, right? Because I have a methyl group here, a methyl group here, and a methyl group there. And so I get 2, 3, 3, and then this one becomes the 7 and the 8. And then there's 5 methyl groups, so I get pentamethyl, and then the parent chain is a decane. All right, so that's about 21 minutes in, plus whatever time you might have taken for these two problems. And we're going to get some more practice in on these as we're going through. But the next thing I want to look at is all the different ways we can draw. So I'm going to take this chance here to pause this segment, finish the segment as segment 1, and we'll pick up with all the different ways we can draw in segment 2. All right, so stay tuned for that, and I'll talk to you soon.